reaction.
A batch reactor is sometimes used for investigation of the kinetics of a chemical reaction in the laboratory and also for the larger scale operations in which a number of different products are made by different reactions on an intermittent basis. It is also used for testing new processes that have not been fully developed, for the manufacture of expensive products, and for processes that are difficult to convert to continuous operation. The batch reactor has the advantage of high conversions that can be obtained by leaving the reactant in the reactor for long periods of time. However, the disadvantages are of high labor cost per batch and difficulty of large-scale production.
Working operation.
Batch reactor is the simplest chemical reactor in the chemical industry. The reactant are placed into the reactor and then allowed to react. The product will form inside the reactor. Product and the unreacted reactant are then removed and the process is repeated. Batch reactor contains porous pot, injecting reactants and removing products, and can be outfitted with heat exchanger and stirring system. These are generally unconstant volume and are designed to maintain the constant pressure by varying the reactor volume.
Evolution of reactor batch technology.
In the early days, when batch reactor was produced, it was observed that there were cloggings of air diffuser caused by the periodic settling of sludge on the air diffusion system in the batch reactor. Also increases the complexity of their operations. Therefore, it causes a competition between the heating and the cooling loops. When that happens, the temperature becomes extreme and there was major energy consumption due to the heating process, ultimately causing the total batch duration to be longer due to the speed of addition of reactants becoming slow at the end of the process.
Besides the advantages of advanced batch reactor in this production, first, by using PCR, which is abbreviated for predictive control for temperature control for chemical reactor. Okay, PCR, it is based on dynamic model of the unit, focused to solve control problems and can be applied to other units such as distillation column and heat exchanger. And the third, it also make possible for the producer to push the process on its limit. Okay, so the common problem in handling the batch reactor in this production is, first, it is difficult to control the temperature due to several factors such as the catalyst. So in a way to curb this problem, heating and cooling are installed to control the temperature.
Description of advanced reactor batch technology.
Hello, hi. Today I'm going to explain about batch reactor control temperature structure. According to the process, reactor temperature is controlled directly by a hot valve steam for heating and through the cool valve for cooling.
Okay, figure 4 shows the general structure of design PCR controller. It's composed by the heating section and the cooling section. Heating section contains block H, which correspond to an enhanced order controller with pure time delay combined with the feed-forward controller. Block H determines the HV set point having an input temperature set point and some disturbance measurement. Cooling section contains block C, R2 and R3, which correspond to enhanced first order controller with pure time delay combined with feed-forward controller. Block C determines the TC2 set point having as an input reactor temperature set point and some disturbance measurement. Block R2 determines TC3 set point, while RT determines the cold valve position set point having as an input TC2 set point and disturbance with flow of fresh water temperature. Each block has a tuning parameter, the closed loop time response, CLTR.
Diagram of batch reactor. advantages of the reactor. Advantages of the advanced batch technology.
Okay, so the first advantages is it can increases the production through shorter batch duration. Second, there is a compartment name which is predictive control, which enhance the quality of process with stable temperature. And the third, cost through small consumption of utilities. And the fourth, flexibility of operation. So batch reactor in this production, basically it can produce one product and also different products simultaneously. And the last, the fifth, high conversion per unit volume for one batch. Thus, it is also easy to clean.
Conclusion.
In conclusion, reactor temperature control by using PCR avoids the competition between cooling and heating loops. Thus, extreme temperatures do not appear and energy consumption is minor. Operating conditions are reproduced better for the different batches due to decrease of reaction temperature variability.
Total batch duration is reduced due to the increase in the speed of addition of reactants. Such as increase is now possible because the deviations in temperatures have been notably reduced. On the other hand, cool value has a margin to give the necessary cooling. An increase in process availability has been identified and a decrease in maintenance costs due to minor control of use.
It is important to note the PCR shows an easier tuning because its tuning parameters have physical meaning, minimizing the necessary time to adjust it. The control technique is suited for the process equipment as in heating and cooling system. So, it is not necessary too much work to adjust the parameter for all the recipes that run at the same reactor.
Reference.